Today we will be talking about solving absolute value equations, and our objective is that we will be able to solve absolute value equations algebraically and graphically. So thinking back to our graphing unit, we have a, h, and k here in our equation. H is 2, k is -2, so we'd start at 2, -2, and we'd go up and over on each side to graph our absolute value function. So what are the zeros, solution, roots, or x-intercepts? They're here and here, so we would know that x equals 0 and x equals 4. For our second graph, a would be -3, h would be -2, k would be 4. So if we start at -2, 4, and then our graph is stretched and flipped because of the -3, we'd go down 3 over 1, down 3 over 1. Same thing on the other side. Where our zero solutions, roots, or x-intercepts for aren't quite exact. They're decimals / fractions. So with our first graph, we would be able to find the solutions graphically. For our second graph, it would be better to find the solutions algebraically. So our steps for solving an absolute value equation. Let's make this a little bigger. The first thing we're going to do is isolate the absolute value. We don't want to have anything else on that side of the equation. We want just the absolute value. Then we're going to write two equations. Next, we're going to solve each equation. We're going to check our solutions. And then finally, we're going to graph on the number line. So in number 1, our absolute value is already isolated. It's by itself on this left-hand side. There's nothing else besides what's in the absolute value. So we're going to go on into splitting it into two equations, one for the positive and one for the negative. And the reason this is if you think about an absolute value equals, let's say it's 5. We're talking about any number that is 5 spaces away from 0. Well, positive 5 is 5 spaces away from 0, but -5 is also 5 spaces away from 0. So that's why we have two equations. So our first equation looks just like the original, but without the absolute value. So 2x minus 5 equals 9. Our negative equation, we're going to take the negative, we're going to put it outside, and our absolute value bars are going to turn into parentheses. So those are our two equations. Now we solve them. The first one, we're going to add 5 to both sides. Get 2x equals 14. Divide both sides by 2, and we get that x equals 7. On our negative equation, I'm going to distribute the negative first. So negative 2x plus 5 equals 9. Then to solve, I'm going to subtract 5 on both sides and divide by negative 2. And I get that x equals negative 2. Now we're going to plug these in to check our solutions. If we plug in 7 for x, 2 times 7 is 14. 14 minus 5 is 9. The absolute value of 9 is equal to 9. So that one's good. 2 times negative 2 is negative 4. Minus 5 is negative 9. And the absolute value of negative 9 is positive 9. So negative 2 also works. So I'm going to have to figure out on here, on my number line, how I'm going to fit negative 2 and 7, which means I'm probably not going to want to put 0 in the middle. So I'm going to put negative 2 all the way down here. So that makes this is 0, 1, 2, 3, 4, 5, 6, 7. And because it's just equals, we just put a closed circle on each of our x values. Now in number 2, we have to do a little bit of work before we can split up into our two equations. So we need to get the absolute value by itself. So I'm going to subtract 4 on both sides. Divide by negative 3. And now that the absolute value is by itself, now I can split it up. So on the positive one, I would subtract 2 first, and I would get that x equals negative 2/3. On the negative side, I could distribute the negative like I did last time, or I could also divide by negative 1. So I would get x plus 2 equals negative 4/3. Then I would subtract 2, get negative 10/3. If I plug those in, they'll both work in my equation. So since they're both negatives, I know they're going to be less than 0. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 2/3 is a little bit more, almost 1. And negative 10/3 is just over 3. So 1, 2, 3, a little bit past that, negative 10 over 3. Number 3, I have an absolute value equal to negative 4. There's something really special about this because it's equal to a negative. Absolute value is the distance for 0, and therefore it is never a negative number. It has to be positive. So automatically, because this is equal to a negative number and there's nothing else to get rid of around the absolute value, I know that this is no solution. You can either write the words no solution, you can draw a 0 and put a slash through it, or if it were using set notation, you can do curly brackets and have nothing inside, meaning the empty set. But the most important thing is you can't have an absolute value equal to a negative. That's not allowed. So let's do that one. Can't have it. All right, in number 4, our absolute value is by itself on this side. So I'm going to split it up into my positive and negative equations. So over here I've got to get my x's together. Then I'm going to get my numbers together. When I divide, I get that x equals 1. On the other side, I'm going to distribute the negative. Then again, I'm going to get my x's together. Get my numbers together. And when I divide, I get x equals 2. So I'm going to plug these back in. So when I plug in the 1, I would have the absolute value of 1 minus 3 equals 3 times 1 minus 5. 1 minus 3 is negative 2. The absolute value of negative 2 is positive 2. Over here, 3 times 1 is 3, minus 5 is negative 2. Those are not equal, therefore this solution doesn't work. It's called an extraneous solution. It's a solution that appears to be when I solve it, but when I plug it back in, it doesn't work. For my x value of 2, when I plug that in, 2 minus 3, absolute value, equals 3 times 2 minus 5. 2 minus 3 is negative 1. The absolute value of negative 1 is positive 1. 3 times 2 is 6, minus 5 is 1. They are equal, so 2 works as a solution. I'll make this 0, this 2, and graph it right there. Something I forgot to mention in number 3, since there's no solution, there's nothing to graph, so we would just leave the graph blank. That's all for today. Fill in your summary, and I'll see you in class.